Hello everyone, I'm Amy, the math tutor at Work Smart Math. In this video, I'd like to talk about mathematical induction, which is a powerful technique used to prove statements or formulas that are true for all positive integers. Let me show you the steps with an example. We need to prove 23 to the power of 3 and minus 1 can be divided by 7 for all positive integers of n. That means when n equals 1, 2, 3, etc., the statement will always be true. The logic of induction has 3 steps. The first step is to prove the statement is true when n is the smallest positive integer, that is, when n equals 1. The second step is we assume the statement holds when n equals any arbitrary positive integer k. And based on that, if we can prove the statement is also true when n equals the next positive integer up, which is k plus 1, then we can say the statement will always hold when n becomes any positive integer. Let's come back to this question. When n equals 1, we substitute n with 1. And turns out this number can be divided by 7 because it gives us an integer. The next step is to assume when n equals k, this expression is divisible by 7. I'm just going to use a little tick to say this is divisible by 7. Okay, and if that is the case, what happens when n equals k plus 1? Will this still be divisible by 7? Alright, before we carry on, let's just review what we have done already. We have proved 23 to the power of 3 minus 1 can be divided by 7, and we assumed 23 to the power of 3k minus 1 can also be divided by 7. So these are the two conditions we know, and let's use that to our advantage in the rest of the working. Let's unpack this expression a little bit. I'm going to do a little bit of manipulation here by creating 23 to the power of 3 and then take away this term because I do not want to change the question. And now I'm going to use a different color, and I would like to show you I created two groups. Here. So for the blue one, the common factor they've got is 23 to the power of 3. So take that out. And for the brown one, I'm just going to put them together like this. Okay. So just reorganize these terms, and as you can see, for this expression, we have assumed it is divisible by 7, and for this one, we have proved in step 1, it's also divisible by 7. And this makes the whole expression is divisible by 7. That means I can get rid of this question mark and put a tick right next to it. Alright, so now we have successfully proved the statement holds when n equals k plus 1. Therefore, we can say 23 to the power of 3n minus 1 is divisible by 7 for all positive integers of n. If you find this video helpful, please give me a thumb up and subscribe to my channel for more. I also offer online tutoring lessons that can be easily booked at www.worksmartmath.com. Why work harder when you can work smarter? See you next time.